Okay, for this second part, I'm gonna start with domain-driven design. The entity, value object, aggregate, services, factory, and repository are the building blocks, also known as the technical approach to domain-driven design. And in this video, I will focus on these three things. The first one is entity. We design a domain object as an entity when we care about its individuality, where we have to determine its identity correctly, and how we are going to obtain it. And the second one is value object. We design domain concepts as a value object when we care only about the attributes of an element of the model and not in its identity. And the last one is aggregate. Aggregates have a clearly defined boundary, so it only care about integrity and responsibility of the object inside the aggregate, and it doesn't care about the external objects. Aggregates protect internal objects from the outside, like the outside objects can only access by the root aggregate and can't change the state of the objects in the aggregate. And there are the rules for making aggregate design straightforward. The first one is to reference other aggregates by identity. This identity will use as the primary key. And the second one is transaction should be processing one command by one aggregate. Like we are going to avoid the temptation to modify two aggregates on a single transaction. In this case, the transaction can be guaranteed to fit within a service boundary and also fit the capabilities of NoSQL database. And there is a question, how to maintaining consistency between aggregates, while we have to avoid the 2PC. The solution is event-driven architecture. All of the things that happen are events, like the customer requests, inventory updates, and so on. The value of knowing about a given event and being able to react to it, and also degrades over time. Event-driven architecture ensures that when an event occurs, information about that event is sent to all of the system. It's simple. When something happens, just publish the event and another service subscribes to the events, then update its own service. The way to maintaining consistency will be like the event cycle as you can see in the video. Each service will get an event that subscribes and publish the new one. The system will do it again and again. This is a rollback that a SID transaction can simply do. But there will be a rollback issue. Like when some business rule would be violated, and then the system will end up having a publishing event, and the event cycle will be broken, so developers have to design the architecture carefully. And the another problem is dual write problem. This problem will happen when the service publish more than one event. The system will be crashed, and actually the event cycle will be broken too, and it's not in the consistent state anymore. To solve these cases, I would like to focus on the thing called event sourcing. Event sourcing is the events that sequentially order according to the time they occur. Every change is stored in the form of an event stream and cannot be modified or changed. Event sourcing is the events that sequentially ordered according to the time they occur. Every change is stored in the form of an event stream and cannot be modified or changed. But there are still limitations in transaction management. Therefore, event sourcing has to be used with the CQRS to break the limit again. CQRS is a form of microservice design that separates the service, model, and the database into the two main parts. The first part is the command layer, and the second part is the query layer, as you can see in the picture. And this is an example, and we use the event sourcing with the CQRS together. When the event sourcing and CQRS were used together, it will reduce errors and useful in many ways, such as: first, there will be more ability to make one service with one database. And about the transaction management, it will be better managed in the atomicity. And also we can check the transaction history information, etc. And for the conclusion, the benefits and drawbacks of event sourcing. The benefits are: first, 100% accurate audit logging, and the second, easy temporal queries, and the last one, applications can process same events but create wheels. And in another side, the drawbacks are: first, adds more complexity, and actually more efficiency, more complexity. And the second one is no strict consistency because it depends on the software design. And the last one, longer boot up times, cause it have to cache the transaction history information. But in this part, snapshots can help. And this is all about the microservice that I want to present to you. I hope you enjoy my video and thanks for watching.